So hi everyone, today we'll talking about what is multi-level classification and eventually we'll be walking through the codes also. So let's get started. So first of all, we'll try to understand what are different types of classification problems. One is binary classification that you must have seen in Titanic dataset on Kaggle. So which deals with just two classes, 0, 1, yes, no, true, false. Multi-class classification, which involves more than two classes and eventually only one of the classes can be the answer. So like categorizing different types of animals, different types of color, trees, etc. Now, multi-level classification can have two classes or more than two classes, but at the same time, it can have multiple classes as its answer and not just one. So, for example, in case of movie genre prediction, a movie can have romantic as well as comedy genre, that is rom-com, suspense thriller, so which is a combination of two genres again. So, in this case, you can have multiple classes for the given entry. This is called as a multi-level classification. Now, solving a multi-level classification is quite challenging at times as compared to multi-class and binary classification. So we'll discuss it why. Because the default implementation of most of the traditional ML models like logistic regression, random forest doesn't support multiple outputs. Second is that if traditional model doesn't support multiple outputs, then we might turn to neural networks. But if your dataset is small, then eventually you are just trapped because you can't use traditional models. You don't have neural networks also performing well. If there is imbalance in your data set, it becomes quite challenging to balance that data set out also, because your normal upsampling and downsampling just won't work. So I'll show you an example why. See this particular data set, a sample multi-label data set where we have three features and their respective classes. In this particular example, we have E, C, and D as minority classes and AB as majority classes. Now, if you go to upsample the minority, that is E, C, and D, you might be upsampling the majority also because the labels are associated, right? So, for example, if you are going to upsample the second sample, ABC, so eventually you are upsampling A and B also. So the ratio remains the same between majority and minority, and vice versa. If you're trying to downsample the majority, you might be removing the rare classes samples also. So in this example, if we go for downsampling for A, you might remove the fourth sample. D also gets removed. So this is why downsampling and upsampling, it doesn't go well with imbalanced data and multi-level classification. So let's try to find out answers for these problems one by one. We might not be able to find answers for everything, but let's get started. So first of all, we're talking about a solution for the problem that we face in the first point, that is traditional ML models don't support multiple outputs. So in this case, we can use a wrapper provided by sklearn, that is multi-output wrapper, which helps you to convert any traditional model producing multiple outputs. So basically, under the hood, you can call any ML model use with this particular wrapper, and eventually it will help you in multi-level classification. So under the hood, talking about the logic, multi-output wrapper implements one versus rest classification. So what is that? So in case of one versus rest classification, the idea is very simple. What we do is that instead of creating single model for all the classes, we are creating one model for each class present. So for example, you look at this particular example. In movie genre classification, assume that we have this particular class: action, comedy, and drama. We are trying. It is a multi-level problem. So for implementing one versus rest, what we'll do, we will create three classifiers: action versus rest, comedy versus rest, drama versus rest. So in this particular case, rest means the other two classes. So it's basically we have created three binary classifiers now internally. Now, when a new movie comes for classification, these three classifiers are used in a combination. Each classifier will give a yes or no, right? Because it's a binary classifier. And eventually, using uh, if multiple classifiers are saying yes, the movie would get assigned to multiple genres. If none of the classifiers say yes, the movie goes without a genre. So in this case, in multi-level classification, you might not get a label also, or you might get multiple label also, because depending upon the performance of the multiple binary classifiers that we have got, eventually the final decision would be taken. Now here is a particular code snippet using which you can implement how you can see that how multi-output classifier can be implemented. And in the core of the model, the core model that we are using is logistic regression. So it's very easy. The first line, as you can see, that x comma y make multi-level classification. So it generates your dummy data set for testing purposes. We are splitting the data set, as you can see. Then we are calling this particular wrapper multi-output classifier, and within that we are passing the logistic regression model as a parameter. We are fitting this classifier, and eventually predictions are getting. So it's very easy to use as we do it for multi-classification problems or binary classification. We're just adding one more wrapper over the model. That's it. Implementing it is very easy. Now next we'll be moving on to neural network based solutions. So assuming that you have already worked with neural networks for binary or multi-classification problem, we will be talking about how you can change the same structure for multi-label classification also. So in case of a binary classification, we are using a sigmoid function in the last dense layer of a neural network. Similarly, in case of a multi-classification problem, we are using a softmax activation function in the last layer, in the output layer of the neural network. In case of a multi-level classification, we need to keep the whole structure same. We can keep it same. Just in the last active output layer that we got, we need to keep the sigmoid activation function there, similar to binary classification. That's it. So in comparing multi-label and multi-classification problem using neural network, the only difference is the activation function that are getting used. So in multi-label classification, the final output activation is sigmoid. In case of multi-class, it is softmax. So now a question comes in ki why this change is required, why softmax activation function can't be used for multi-level classification. So let's understand with an example. Assume that we are going for animal classification with three levels: dog, cats, and birds, and this is the final output: 2.1 minus 1.5, 0.8, before applying the activation function. Now if sigmoid activation is applied, 0. We are getting 0.8, 0.1, 0.68. So here you can see that the sigmoid, the final output that we generated for all the three classes, is independent of each other, right? These doesn't add up to one. These are not probabilities. So eventually, using this final output, you can have multiple classes in your output. But when you use softmax, for the same final output, you get 0.7, 0.02, 0.2. So eventually here you can see that they add up to 1 and they are interdependent to each other. So when you're using a softmax function, only one of the classes can be a final output. But when you're using a sigmoid activation function, multiple classes can be your final output, because the final output that we get isn't dependent on each other for each of the classes. The codes looks quite easy. Here we are doing the same thing. Using the make multi-level classification function from sklearn datasets, we are creating a dummy dataset. Train test splits is done. Then we are creating a baseline keras based neural network, and then eventually in the last you can see that activation is sigmoid. Now if you change this activation to softmax, this whole neural network becomes a multi-classification model. That's it. That's the whole difference, and rest of the things remain the same. Now, talking about the last one, that is handling the data imbalance that I talked about previously. So that is a very tricky solution, and eventually I was trying to figure out solutions, some more scientific solution, but I couldn't figure out anything on how to handle data imbalance in multi-label classification problems. So one of the solutions that I thought of is that we can go for model stacking. So in that, what we can do, we can detect what are the minority classes in a data set. Detecting is using some threshold. Then we group these minority classes as one group, call them as group X, for example. Now train the base model on the majority class and the group X. Basically, don't forget that group X is the combination of all the minorities. Now, once your model A is trained, train another model B just on group X. Don't include group A. So, and eventually, using a combination of these two models, any prediction made by A which has label X now should be fed to group B, should be fed to model B for further predicting the minorities from group X. That's it. This is a logic that you can try out. I tried out for one of my problems and gave me decent enough results. But so in this way, you can solve out your multi-level classification problem through three ways. One is the multi-output parser that I talked about. The second one was neural networks, and third one is like grouping out the minorities and then eventually using model stacking.